You've got wireless internet, wireless headphones. Your entire life is wireless, except for the most important thing, the power cord. Why are we still so tangled up? I mean, seriously, think about it. We can stream a 4K movie from halfway around the world through the air with zero effort. But the electricity to power the TV it's playing on? Nope. You gotta plug that into a hole in the wall. It feels backward, right? And here is the truly wild part. This isn't some new idea. More than a century ago, a certified genius promised to power the entire planet for free with no wires. His name was Nikola Tesla. So, what went wrong? Why isn't his dream our reality? First up, let's talk about the dream. Because to understand why it failed, you first have to grasp just how mind-blowingly ambitious Tesla's vision really was. This wasn't about charging your phone. It was about rewiring civilization itself. This guy was the original Tony Stark, no joke. Radio, remote controls, the electric motor, he basically invented the modern age. But his one great, unfinished masterpiece was broadcasting power through the air. He imagined a world where electricity was just like the air itself, everywhere and free for everyone. Which brings us to the physics buzzkill. So why did this incredible dream die? Was it corporate greed? Some big conspiracy to keep us paying for electricity? The truth is actually much bigger than that. The thing that killed Tesla's dream was a fundamental law of the universe. It all boils down to one simple, absolutely unbreakable rule: the inverse square law. It's the reason the sun can give you a sunburn, but the stars can't. And it's the exact reason you will never, ever be able to charge your phone with a Wi-Fi signal. Here, think of it like this. You shout. Someone standing right next to you hears it perfectly. But if you move twice as far away, the sound isn't half as loud. It's 1/4 as loud. 3 times as far away, you're down to 1/9 of the power. The energy just spreads out and vanishes into nothing. And this is what that law looks like on a graph. It's not a gentle slope, it's a cliff. Just a few meters away from the source, and the power you can actually use drops to practically zero. This chart right here, this is the dream killer. This is the brutal math that made worldwide wireless power impossible. Okay, so on to charging pads, the workaround. If that law is so powerful, how in the world do those little wireless charging pads on our desks work? Well, it turns out they're not really broadcasting power at all. They're cheating. See, today's charger is used with called magnetic induction. A coil in the pad creates a tiny, weak magnetic field. A second coil in your phone has to be sitting right inside that field to turn it back into electricity. It's less like a radio broadcast and more like a very precise, very short-range, invisible handshake. But that convenience? It has a price. And that price is an energy tax. Look at this. To put 15 watt-hours of juice into your phone with a cable, it takes, well, 15 watt-hours. Duh. But to do the same thing with a wireless pad, you have to pull 21 watt-hours from the outlet. That extra energy just gets wasted, mostly pouring off the charger's heat. And that heat is a huge problem. Over time, it literally cooks your phone's battery, reducing its lifespan. On top of that, they're often way slower than a cable. We've all had that moment where you bump the phone just a tiny bit and the charging stops. Oh, and get this, nearly 1 out of every 5 wireless chargers sold in 2024 are uncertified fakes. Yikes. So that brings us to the cool stuff, beaming power through air. Okay, so broadcasting power in all directions is a massive waste. But what if we stopped broadcasting and started beaming? What if we could focus all that energy into a single, tight beam, like a laser pointer? This is where it gets really sci-fi. Exactly. Instead of an inefficient light bulb, imagine a super efficient laser. That's the core idea behind microwave power transfer and laser power transfer. We're not talking about charging phones on a desk anymore. We're talking about beaming kilowatts of power across thousands of meters. And the potential is just staggering. I mean, look at these numbers. Microwaves hitting over 60% efficiency from a mile away. Lasers sending enough power to run appliances over a kilometer. This is the kind of tech that could power drones in midair or beam solar energy down to Earth from space. So, problem solved, right? The future is lasers. Awesome. Well, there's just one tiny little question that we have to ask. A question that kind of turns this whole sci-fi dream into a potential nightmare. Let's be real, we are talking about a focused, invisible beam of energy, powerful enough to run a machine. You can't see it, you can't hear it, and you probably can't feel it until it's way too late. So, what happens if you accidentally walk right through it? 4.6 kilometers. Just let that number sink in for a second. That's almost 3 miles. Get this. For one of these proposed power beaming lasers, that number is the official nominal ocular hazard distance, In plain English, that means for the entire 3-mile path of that beam, it is powerful enough to cause permanent, instant eye damage. The danger zone isn't a small area. The entire beam is the danger zone. Let's enter the real wireless world. Okay, so beaming high-powered invisible death rays through our cities is probably off the table. So what does the future actually look like? Well, it's not about one magic bullet, it's way smarter than that. Here's the real takeaway. You use the right tool for the right job. For close range, yeah, charging pads are awesome for convenience at your desk. For long range, that dangerous beam stuff is actually perfect for places where people aren't, like inside a sealed factory to power robots, or way up high to power drones. But that true mid-range room-scale power, that's still the holy grail. That's still the really big challenge. So Tesla's dream of a world with absolutely zero wires, it's probably not going to happen. But a new, more practical dream is taking its place. It's a future where you never have to think about charging again, because the charger is just built into the world around you. It's in the desk, it's in the nightstand, it's in the cup holder of your car. Power is just there, waiting, invisibly. Which really brings us to the final thought. In a world like that, where you never have to search for an outlet again, where power is just always available, what does that unlock? What new things could you invent? What's the very first thing you would power up?